Okay. So curve is sketching the curve which they have given. So we will see that curve. Before that, just try to understand that the double derivative, which we have studied earlier also, it has a very significant role. So double derivative, which is f double dash of x, if it is greater than 0, then the curve is concave upward. And if double derivative is less than 0, then it is concave downward. And if
Okay.
it is concave upward, then there is chance of getting minima at somewhere. And if there is concave downward, you will get maxima somewhere. So now let us see this sketch and try to understand what it is trying to say basically. So we have this curve which is like this. Then it goes like this. Then it goes like this. Then it goes like this. So if you observe different region, so this is a point where change occurs. This is a point where change occurs. This is some point where change occurs. What is that change? Just see. If you see this portion of the graph, this is concave downward. Okay, this portion is concave downward. And then if you see this portion of the graph, it is concave upward, right? It is concave upward and that is concave downward. Then if you see this portion of the graph again, so it is concave downward. And then you again see this portion of the graph, this is concave upward. So this is concave down. Can you figure out the difference between the nature of graph?
Uh,
Sathya?
isn't it like um
Something like this is concave downward, something like this is concave upward.
yeah, yes, sir, I know that.
Okay.
Yeah.
So this is what we are observing here. Now every point which is for concave downward, suppose we are taking any point in concave downward here. Let us take any point, this point I'm taking, this P point. So the double derivative at this point has some x, some y. So if you double differentiate the curve and put the value of x, what you will find that the double derivative is actually coming out to be less than 0. And if you take any point in the region of concave upward, what you observe that the double derivative is greater than 0. Okay.
Okay.
So this is what it is saying. Next thing it is saying that for concave downward, there is a maxima. So here you can see there is a maxima. If you talk about a region which is concave downward, you will get a maxima somewhere. And if you talk about a region which is concave upward, you will find that there is a minima. Similarly here, concave downward, there is a maxima. And similarly here, concave upward, there is a minima. Is this clear?
Yes, sir.
So this is what the first slide is talking about. And one more thing they are saying that if double derivative 0, so these green dots which I made, this dot, this dot, this dot, these green dots are there. what happening, these dots are the boundary line, boundary dots, from where the nature changes. They say there is a concavity change. So if double derivative is equal to 0 and there is a concavity change, right? So in that case, it is called point of inflection. The point is called point of inflection. You can write this. So all these green dots, there is a concavity change, either from upward to downward or downward to upward. These are the point of inflection, and the derivative is equal to 0.
Done, sir.
Okay. So no doubt here.
No, sir.
Okay. Next, they have taken a graph and they have almost telling the same thing that what is point of inflection? Point of inflection is where the concavity changes. Like here, they have taken a graph like this. And since it is concave downward, and here it is concave upward. So this or this here, this is the origin 0, 0. This can be called as point of inflection here. Or it can be vice versa also, like even if it is like this, like then also concave upward to concave downward, then also the same thing. So you can write this also. And now we come to the question. So the question that they have given is fx is equal to 1 by 3x cube plus 4x square minus 5. And you have to find the intervals of concavity. So for that, you have to first find the double derivative. So single derivative and then double derivative. So first just try to find out single derivative and then double derivative. Then we will see the change in sign. I think I have to stop the video because it is, I think, network issue may be there. Oh, it is better.
Okay.
It is no
Okay,
better.
sir. So should I switch it off?
No, it is fine now. Earlier it was flickering.
Yeah, yes, sir. I noticed that. So the point of inflection is it the 0, 0?
Yes. Double derivative is 0.
So is it always 0 or like
It has to be 0 as well as
Because it says
Like,
it is where the function changes concavity.
yeah, actually, it is the point where the function changes its nature of concavity.
So it can be
So,
any point.
yeah, it can be double derivative could be zero or also undefined also.
Okay.
Or even there are few or more concepts, but we don't have to go into detail of that. You have to just think, have you got double derivative? Can you tell me what is double derivative?
It's like the derivative of the second
Derivative.
derivative of the
Yeah,
first one.
second derivative. Yeah. So have you got that?
Oh, of this question? No, 1 minute, sir. Just a minute. So the first derivative is 8x square plus 8x,
X square plus 8x, right?
and the second derivative will be 2x plus 8.
2x plus 8, correct. Now, we have to see where the second derivative is positive and where the second derivative is negative. So for this, we will take 2x plus 8 as positive and 2x plus 8 as negative. Now, here, if you take x, 2x greater than minus 8, or you can say x greater than minus 8 by 2, that is minus 4. Okay. Here, x, 2x less than minus 8, and x less than minus 8 by 2, minus 4. So what we observe that intervals of concavity is if double dash x is less than 0, this is less than 0, in which interval? It is less than 0 in the interval x less than minus 4. And if double dash x is greater than 0, where in the interval x greater than minus 4. So here minus infinity to minus 4, you will say that it is concave downward. And here you will say minus 4 to infinity, it will be concave upward. So this will be the answer.
Yeah. So is it always, will the y always be the infinity?
Y, no, no, not y. X is less than minus 4. No?
No, y, sir.
Y is fx. This is y.
No, sir. In the points, we have -4, infinity, and minus infinity and -4.
No, it is on the number line. Number line. You are getting x less than s greater than minus 4. So for x greater than minus 4, how will you write this? X greater than minus 4. You will say that it is minus 4 to infinity. This rightmost region is infinity. And x less than minus 4 will say that it is minus 4 to leftmost region is minus infinity.
Okay.
It is on the x-axis. So this is negative x-axis, this is positive x-axis. So this will go to endlessly. So minus infinity. This will go endlessly to plus infinity. So when we write the intervals, we will write it like this. You can write it as like this also, greater than minus 4, less than minus 4. But if it is given as an interval, you have to write it like this.
Okay. I'm sure.
Done this. Now, now this x equal to -4 here is the point of inflection, because they are not asking what is point of inflection. But if they will ask, you will say that x is equal to -4 is the point of inflection, because it is changing from concave upward to concave downward at this point, right?
Yeah.
Now, next question which they have given, I want you to try on your own. That question is x root over x plus 1. Fx is equal to x root over x plus 1. So you have to find the interval of concavity. Would you like to try?
Yeah, I'll try. So So, I have a doubt.
हाँ सत्य बोलो.
Sir, in this, we use quotient rule, right?
In this we use product rule.
Product, okay. Okay, sir. Sir,
हाँ साथ है बोलो. Yes साथ है.
sir, I did the product rule and I got x
You
into
did the
half.
first derivative of this.
Yeah, I got that.
So 1 minute, 1 minute only.
Yeah, yes, sir.
Yes, sorry, Sathya. What is first derivative?
I got x into half into x plus 1 raised to minus 2.
Minus 1/2.
1 by 2, yeah, sorry, 1 by 2 plus x plus 1 raised to half, raised to 1 by 2.
Correct. Then
So then how do we get the double derivative of this?
double derivative. So first you have to do one thing. X by 2 and x to the power minus 1/2 is actually root over x plus 1 in the denominator. And x plus 1 to the power 1/2 is root over x plus 1 in the numerator. Now if you take the LCM, this will be 2 root over x plus 1. And it will be x plus 2 into x plus 1 after taking LCM. So this will be 3x plus 2 by 2 root over x plus 1. So first you need to simplify. After you have simplified it, you will take the second derivative. Now you have to apply the quotient rule. Would you like to apply or should I do?
I'll try, sir.
Okay, try. This is u. Half will come outside. It is a constant. Till what time you have to take today's class, Sathya?
I think today is 2 hours, right, sir?
2 hours. Okay.
Sir,
Yes, Satya.
I got negative 4 root x plus 1 by 4 into x plus 1.
Okay, first tell me the first step. What you have written in the first step?
Uh, the first, I derivated it as 3 plus 0,
Hmm. In quotient rule, first tell me the denominator.
uh, 2, 2 root x plus 1 the whole square.
That will become x plus 1. Okay, now we come to the numerator.
Then I 3 plus 0 into 2 root x plus 1.
So actually, 2 we're taking the numerator. 2 is a constant. It will simply come outside because if you are taking 2 in the numerator, then the whole square will be on 2 also. Have you done whole square on 2 also in the denominator?
Yes, sir.
Okay, then it is fine. So then 2 root over x plus 1
Into 3
into
plus,
3.
yeah,
Oh,
into 3 minus 3x plus 2
okay,
uh, into 2 root x plus 1
into 2 root x plus 1 in the numerator or in the denominator.
numerator.
But when you differentiate root x plus 1, on differentiating, this will become 1 by 2x plus 1 to the power minus 1 by 2. This is 1 by 2 root x plus 1. Isn't it so? So it should be 2 by 2 root over x plus 1. You have to differentiate this now. V square v u dash minus u v dash. That is differentiate v. Isn't it so?
Yeah,
This is the differentiation of v. Root over x plus 1. When you differentiate, you get this. Okay.
yes, sir.
So this would be equal to this 2 and this 2 cancels. And this 3 into 2, 6 root over x plus 1 minus 3x plus 2 by root over x plus 1 upon 4x plus 1. So this will be equal to 6. Now you have to take LCM root over x plus 1. So it will become x plus 1 minus 3x plus 2, and in the denominator 4x plus 1, and the root over x plus 1 will also come in the denominator. Isn't it so?
Yeah, yes, sir.
So in the next step, what we will do, this is equal to 6x minus 3x will be 3x, 6 minus 2 will be 4 by 4x plus 1 into root over x plus 1. This is what we are getting. Now you have to see the concavity or upward or downward. So you have to see what are the critical points where it is becoming 0 or undefined. So if you equate it to 0 or undefined, so you have 0 at minus 4 by 3, when 3x plus 4 will be equal to 0, that will be x is equal to minus 4 by 3. And when x plus 1 will be equal to 0, either here or here, both is x plus 1. That is x is equal to minus 1. Then it is undefined. For undefined, this is for 0, this is for undefined. X is equal to minus 1. Now, if you see the regions, what we used to do, this is plus, this is minus, this is plus, this is the sine scheme which we used to do.
Yeah.
Okay. So if we know this sine scheme, we can say that f double dash x is less than 0 for x between minus 4 by 3 to minus 1. And f double dash x is greater than 0 for x from minus infinity to minus 4 by 3 union minus 1 to infinity. So this is the region of concave downward, and this is the region of concave upward. Okay.
So where is the where do we get x plus 1 equals 0 from?
Where?
X plus 1 equals 0. Isn't it root x plus 1?
Yeah, so x plus 1 into root x plus 1, if you multiply them, you will get as x plus 1 to the power 3 by 2. That is, this is power 1, this is power half. So this would become equal to 0 when x is equal to minus 1. This will be combined and can be written as, finally, you can also write it like this, that this is 3x plus 4 upon 4 into x plus 1 to the power 3 by 2.
So then where's the 4 going? Should we also include the 4?
Should not be.
Should we not include the 4?
4 cannot be 0, no?
So we'll just ignore that?
No, we are seeing the sine scheme. Sine scheme, we want to get the value of x, where x is becoming 0 or undefined. We used to do this, no? That when we get a function in x and want to do the sine scheme when x is equal to 0 or undefined. So we see that where it is 0, so where 3x plus 4 0, where it is undefined, where x plus 1 equal to 0. That's it.
Okay.
4 cannot be 0. 4 is a constant.
Yes, sir.
Should from here you have to write, right?
No, I wrote, sir. I wrote till 3x plus, yeah. So can you scroll down?
Maybe more.
Done, sir.
Done.
No, sorry, this one I didn't write. No. But how do you know which one is downward and which one is upward?
Where double derivative is positive, that is concave upward, which is double derivative is negative. Concave downward.
Sorry, sir, which one? If the double derivative is positive,
Yeah, that is concave upward. Is written now. That is what we have done first during the start of the class. Let me pick up a call.
okay, sir. Done, sir.
Okay. So have you understood how we have
Yeah,
to approach these questions? So
yes,
if
sir.
you have any assignment related to this, we can do that right now. So
Yeah,
that
I
it will
have.
be
Yes, yes. So can you see?
yes, yes, I can determine the number of points of inflection for the graph of a vector. So how many number of points of inflection are there?
So isn't it 0?
But what is point of inflection?
It's where the function changes concavity.
So at x is equal to 0, is it not so that it is becoming from concave downward to concave upward?
But it should be touching the, like, shouldn't it be like touching each other or something?
But still that is a point of inflection because function is not defined, but the graph is changing its nature.
So it's 0.
Right? X is equal to 0 is the point, so the number of points are 1. Look, what is happening over here? If conceptually we see it, I hope this should be the answer. I don't know if they have given another thing as answer because they give technically those questions which are controversial maybe for some of the people, but if you see correctly that this is the graph and then this is going to be the graph. Now, just see over here that the graph is here concave downward,
Yeah.
concave downward, and here the graph is concave upward. This point is a point where it changes its nature from concave downward to concave upward. So x equal to 0 is the point of inflection. So there is one point. So you should ideally say that there is one point.
So that point is 0.
Yeah. But still, I'm not sure. Sometimes they give answer, but still 90% chance is that it should be one.
Okay, so there's only one point then.
Yeah.
Okay.
When does the function have a point of inflection? Yes. So what you have to do,
Double derivative.
what will be the double derivative?
1 minute, sorry. Two. I only got two.
Only two. Will it be 0 at any point? 2 can never be 0.
Yeah.
Whatever x you take, there is no x there. So never.
Isn't it 2 minus 4?
But it is f double dash x. What is happening here that you are getting?
I got f dash double dash x as 2.
As 2, which is positive everywhere. There is no interval. So it is concave upward everywhere. There is no place where it is concave downward. So it is not changing its nature. This graph is simply like this.
So can't we put it as like less than great less than 0? We can also put it like that, right?
No, the double derivative is not equal to 0. No? The double derivative is never equal to 0 here. So there is no
But,
point of inflection.
but like we can also write it as in the last one, like we wrote f dash x is greater than 0 and f dash x is less than 0.
F double dash x.
Yeah, double dash x. So
So
why
here f
can't
double dash x is not less than 0. No? It is always get in earlier one. We were getting a function of x. What we were getting a function of x. That is why we drew a sine scheme when it is positive, when it is negative, when it is positive. But if in double derivative you don't have x at all, you have 2, which is a constant, and it is positive. It is greater than 0. So it is not dependent on x. It is independent of x. It is always positive. It is always concave upward. It is not equal to 0 also because it is positive. No point of inflection. It is not dependent on x. It is not like that f double dash x is equal to x plus 2. Then you will say, okay, x plus 2 will be equal to 0 when x is equal to minus 2. Then minus 2 is a point of inflection. But it is not so, na?
yeah.
Getting the point.
Yes, sir. So it's never. Is it?
It is never no point of inflection.
Yeah.
So the function this is concave up on which interval? So first find the double derivative of this.
I got 6x minus 6.
Yes.
So I can write it as,
No. Yes, yes.
can I take it common, 6 common and write 6
Yeah.
into x minus 1?
Yes, yes. Now, for concave upward, what is the condition?
Concave upward, it's f of x is greater than 0.
Not f of x, f
Double dash
double
x.
derivative.
Okay.
So 6x minus 1, which is the double derivative, is greater than 0. When it will be greater than 0?
When it's concave upward.
Yeah, that is the condition. Now, what value of x?
It should be 6x minus 1.
Greater than 0, right? So what will be x?
So uh, f double dash x uh, is greater than 6x minus 1.
F double dash x is 6x minus 1, which is greater than 0. It would be like this now.
Yeah, yes, sir.
F double dash x is equal to 6x minus 1. Now, for concave upward, it should be greater than 0, right? Now,
Yeah,
this means x minus 1 should be greater than 0 because 6 is dividing 0. It will become 0. So, x is greater than 1. Is it okay?
yes, sir.
So, you will say from 1 to infinity. Is there any such option?
That is x greater than 1.
Yeah, you can say x greater than 1.
So it's fine, it's x greater than 1.
Yeah.
So is it also the second one? 0 is greater than x, that one?
No, it is not between 0 and 1. It is greater than 1.
Okay.
Determine the number of points of inflection for the graph of fx. Yes.
So this is 1.
Hmm. Right.
Is this 2?
Yes. So only 2.
Yeah.
Here also you have to do the same question, same thing.
So uh, 1, 2, is that only 2?
You are saying it is 2, 1, 2. Yeah, right.
Okay.
So. The first derivative test is used to find points of inflection. Yes or no?
False.
False. What it is used for?
Second derivative test is used for point of inflection,
Yeah, correct. And what the
while
first derivative test is used for?
I think, isn't
For
it for
finding. Yes.
1 minute, first. Is it for finding the
critical points which help us to find maxima or minima.
Okay. Okay.
Right?
Yeah.
Is concave down on which interval? Now you have to find its double derivative. Just try this. Would you like to try?
Yes, sir. So I'm getting x squared plus 1
1 second, I am writing it.
Yeah.
So it is 1 by x square plus 1. What is the first derivative?
The first derivative I got as x squared plus 1 minus 2x.
X square plus 1 you are getting where? In the numerator?
Numerator.
No. How will it be x square plus 1 in the numerator? This is actually x square plus 1 to the power minus 1. So when you will differentiate it, n x to the power n minus 1, it will work like this. Nx to the power n minus
Is
1.
it not the quotient rule?
Quotient rule also you can apply. So in that case, what will happen? Let us do it by quotient rule. But why to go by quotient rule? Anyways, if you have tried by quotient rule, let us do that way. So in that
Yeah.
case, it is x square plus 1 whole square in the denominator.
Yeah.
Okay, then
Oh, minus how is it 2x, or isn't it?
oh, is it is 0.
Yeah.
Okay, then
Mine isn't it plus minus 2x?
where?
So what I got is 1 into x squared plus 1 minus 2x plus 0 into 1.
No, it will be if you are applying quotient rule. This is u, this is v. So this is v square, then this is v. This is the derivative of u. So derivative of u is 0 because 1 is a constant. Minus 1, derivative of v is 2x, like this. So this will be finally minus 2x. 0 part will vanish. X square plus 1 whole square, like this.
Yeah. Yes, sir.
Then you have to differentiate it once more.
So don't we have to open the bracket?
No, no, not no.
So f double dash x, right?
Yes.
Do we use quotient rule again?
Yes, quotient rule will be used again.
Okay.
Don't take -2. It will unnecessary make it difficult. Take -2 outside. X by x square plus 1 whole square. -2 will be later multiplied.
Yeah. So can we open the bracket inside or should it be in square? Because we have a square again, right?
No, no, don't need to open the bracket.
Yeah. Yeah.
Have you got Sathya?
No, sir. What I got is x to the power 4
Okay.
plus 2x.
Okay, just see. -2, don't do that. It will unnecessarily create problem in calculation. X square plus 1 to the power 4 it will be. And then x square plus 1 whole square it will be into 1 minus x into 2 into x square plus 1. And further you will differentiate x square as a chain rule, x square plus 1. So that will be 2x. This is how you have to do this first step.
So I did it as 1 into x square plus 1, the whole square,
Yes.
minus 2 into x square plus 1
Yeah.
into x.
Into 2x is also there because when you differentiate x square plus 1 whole square, this is a chain rule, na? X square plus 1 whole square you are differentiating.
Yeah.
So this is 2 into x square plus 1, and further there is a inside function which is x square plus 1. So you have to differentiate x square plus 1 also, and that means that it is 2x.
So we don't have not we shouldn't we not put x. Okay, so add 2x.
Yeah, multiply 2x. So this would be minus 2 x to the power 4 plus 1 plus 2x square. This will become minus 4x to the power 4 minus 4x square by x square plus 1 to the power 4. This would become minus 2 minus 3x to the power 4 minus 2x square plus 1 in the numerator by x square plus 1 to the power 4. When you will split the middle term here, first take minus outside, it will become plus 2, 3x to the power 4 plus 2x square minus 1 upon x square plus 1 to the power 4. Now you have to do the middle term splitting. I'm not doing the intermediate steps. The intermediate step would be, you will write 2x square as 3x square minus x square. In that case, it will become 3x square. It will be x square plus 1 minus 1.
So where is the minus go? Isn't the minus 2 there?
Sorry,
Isn't it minus 2 outside
minus
bracket?
minus, it is becoming plus now.
Okay, yeah, yes, sir.
I've taken minus common from the inside bracket from every term. Just see this. So is this clear?
Yes, sir.
Okay. By x square plus 1 to the power 4. Now 1x square will cancel. 2 into 3x square minus 1 by x square plus 1 cube. It is a difficult question. Anyways, so till here we have got the final simplified form. Now they are saying that it should be concave downward. So if it is concave downward, f double dash x is less than 0, which means 2 into 3x square minus 1 by x square plus 1 cube should be less than 0. Now the denominator is x square plus 1 whole cube, which is always positive. It will never be negative since it is x square plus 1. 2 is also positive. So 3x square minus 1 should be negative. So x square should be less than 1 by 3. So x square is less than 1 by 3 means x is between 1 by square root of 3 and minus 1 by square root of 3. Is there any such option?
So there's only minus 0.5 and 1.
Can you show me the questions? Minus 1 by root 3 is 1 by root minus 1 by root 3 is 1.7 and reciprocal of 1.5 is 0.8. It is approximately minus 0.8 to 0.8.
Yeah, minus 0.5 greater than x, greater than 0.5 is there.
Yeah, so that is actually within this interval. So you can take that as the correct answer. If you want to write the steps, you can write them.
Yes. Yeah, answer.
Okay. So let us come to the next question.
I think that's it.
Okay, that's it. 7 questions.
Yeah.
Um, Let us keep our fingers crossed. Last time it was 8 out of 10. Let's see what happens this time.
Oh, I think so. This one is wrong.
Yeah, I knew at some point they gave some. And how many total? Total.
I got 6 out of 7.
Okay, the first one is wrong. So I knew that they might be making some problem in this question. Still, it is
But everything else was right.
all right. Okay. Inflection, questions of inflection you did quite correctly using the graph.
I think only this one was wrong.
Yes. So what next we have to do?
So I think revision, because I think at 9.5.
What was that? Can you just give me an idea of what was the topic there we used to we were doing there?
Oh, the 1 minute. Uh, that one is unit 2. This one, the derivations.
Grades of derivatives. Once you have to show me, I don't remember exactly which we are doing there. Derivatives and their
So now I think I can revise myself because I think the exam is. I think I have to join soon.
okay. So if you will go through these slides, you will just see those steps which we did, like slope of tangent, equation of tangent,
Yeah, this one.
because we have done more than that right now. So these things will not be so much of a problem now.
Yeah. Yeah. And then this other one. So can you see the screenshot?
Yeah, I can see
This one.
this one that we used to find the equation of the tangent line on the M, then find the B.
Yeah, sorry.
Product rule. Example of product rule. Okay.
And then chain rule.
Yeah, chain rule, quotient rule first. And chain rule. Okay, chain rule was first. And
Yeah, these are all.
chain rule we have used just now also. Quotient rule also we have used.
Now it's then its application. That's fine.
Application date of change.